The purpose of this presentation is to show you how to set up your solution to a typical kinematics physics problem. It reads, a car starting from rest accelerates at 2 meters per second squared. Okay, notice that it's positive 2 meters per second squared. What is the car's velocity in 5 seconds? The first step is to write down the given information. If you look at the first sentence, it tells us that the car is starting from rest and accelerates at 2 meters per second squared. So we have the original velocity is equal to 0 meters per second. The acceleration is positive 2 meters per second squared. And then the next sentence gives you the unknown and the time, which is another piece of given information. So delta t is 5 seconds, and then the unknown is the final velocity. So I wrote VF, which stands for final velocity, is equal to question mark. That's a good way of showing the unknown. Next, I'm going to show you how to draw a diagram. Okay, so I'm going to show the car in two places, the beginning of the story and the end of the story. That's the end of the story. So here, I'm going to write VF, and I put an arrow here. The length of that arrow is proportional to the magnitude of the answer. Okay, so I'm just taking a guess there. Okay, there's nothing sacred about its length. You just want to show that it does have length, and of course that it's pointing to the right. The acceleration is to the right and is equal to 2 meters per second squared. The length of this arrow is arbitrary. Remember, I don't have a scale here. You wouldn't draw this equal to this in length if they have the same numerical value because they're two different creatures. So the length of this is arbitrary. And then VO here is simply equal to 0. So I'm not going to put an arrow there because it has no length, the arrow, because it's a 0 velocity. Now time. The way I show time is I use parentheses like this, delta t, time. The next step is the equation. And we really have one equation for acceleration, and that's that the acceleration is equal to the final velocity minus the original velocity over the time. Next, notice I didn't substitute in any numbers yet. Next, solve for the final velocity. So we have the final velocity is equal to the original velocity plus the acceleration times the time. The next step is to substitute in the given information. 0 meters per second plus 2 meters per second squared multiplied by the time, 5 seconds, and we get 10 meters per second.